We talked about lists previous time, but I think lists are pretty important. I'm not sure that everybody is familiar with this concept. That's why I want to talk a little bit about that. If you have experience with programming, then basically Grasshopper lists are arrays. So, but if you're not using programming terms, so a list is a sequence of items, and it's a numbered sequence of items. Items can be of different nature. It can be numbers, it can be text, it can be curves, like any geometrical object, like basically anything can be an item on the list. And these items are presented in a particular sequence and then numbered. These numbers are called indexes, and the first element, the index of the first element is not 1. The index of the first element is 0. So, and then each next element has like next index, 0, 1, etc., etc. It means that the last element of an array, it has an index, like it's the index of this element less like than number of elements. So for example, this array has 3 elements and the last index is 2, because indexes start with 0. Okay, so these are examples. So for example, this is a list of 3 numbers, 5 minus 3, 0, 4, and they're in a particular sequence. If, for example, this array would be minus 3, 5, 0, 4, it will be a different array. So sequence is important. 5 minus 3, 0, 4, it's the array of numbers. It is another example. It's an array of curves. It's some curve defined, for example, in the Rhino somewhere, or another curve. It can be defined in a different way. But basically, these two curves, they're saved. Information about them is saved in this array. And curve 0 we can reference as a element 0 in this list, sorry, in this list. And next curve can be referenced as a curve with under index 1. Now questions to you. For example, this array has two identical, this list has two identical elements. Is it possible or not? What do you think? Is it a correct list? Anybody? Just a moment, I will open chat. If you want to type, please type. If you want to answer, unmute and answer. Guys, we need some feedback from you, because if you understand it, it's fine. If you do not understand it, it's hard. You just during this lesson, you will see how complexity increases every 10 minutes. If you do not understand basics, you should be familiar with basics. That's why I am asking. And if it seems to be a stupid question, like just answer it, because it will indicate how well you understand like what we're talking about.
I think that the list could just be 5 and -3. Like,
Okay, so you mean that repetition, like it shouldn't repeat?
I think so.
I see. Okay, okay. Like anybody else? No. Okay. Annette, no, it is not the case. So in a list, items on the list are completely independent. So it can be the same number. Like they're different. They're just numbered items, and the value doesn't matter. It can be any. Items are completely independent, and there are no rules how like items can correspond between each other on a list, if we are talking about a list. Now, this list has only one element. Is it possible or not? No? Anybody? Yeah, and the index is 0, of course. Yeah. Okay. So yes, it's possible. Lists, yeah, its number of elements, it's limited from the top, so it's more than 2 millions you can have. But yeah, it's possible an array can have one element. I'm not sure if Grasshopper supports empty arrays, empty lists. In programming, it's common. You can start with an empty array and then add more elements. I'm not sure about Grasshopper, but if we're talking about list with a particular number of elements, it's all like one element is normal. Okay. Another question, and I want you to ask this one. Is this array possible? Like 2 numbers and 1 curve. Yeah, anybody?
Yeah, it should be. I don't see why not.
Yes, Elsa, you're right. So it's basically it's like from what I said before. Items are completely independent. They can be anything, and yes, it's possible to have mixed items of mixed nature on the same list. It's dangerous. It's not a good practice. You can screw up your algorithm and it won't work. And then you will have hard time figuring out why it's not working. It's better to keep your lists with items of the same nature, but it's absolutely possible. You can have numbers and curves, for example, on the list. Okay, and this is an array with indexes which start with not from 0, like from 5, like 5, 6, 7. Is this array possible? No, it is not possible. So all arrays, they start from 0, 0, 1, 2, etc. It's sequential and start from 0. If we, for example, this element now doesn't matter what this element does, but one of its outputs, it's an array of points. And you can see, yeah, if we create a panel, just a moment, I want to create a panel from it. So just to show what the array, like what we now have in this list. So this element produces several points, and you see on the left side we have index, and then the point. Index and 3 coordinates of a point, and it all starts with 0. So it's a list of points, and indexes are shown here, and then the points itself, like the item itself, is represented on the right. So that's all what I wanted to mention about lists, and I think that we are good to go forward, and Eric can introduce his model.
All right. Share screen. So today we'll primarily be working with the random component. And basically what the random component is it generates value of random numbers that you could place into other components. So you could find that in the sets tab at the top, sequence, and at the bottom it'll be the icon with the the cat in the box. So there's three inputs that we're concerned with. We have a range of numbers or values that that the component can choose from. We can define how many numbers of that range we will choose. And C basically means a set of random numbers in which the component will generate. So every number that's placed into the seed will generate a random set of values. So the exercise will start off right now is just taking a point value that we've created in Rhino and moving it a random distance. So very simple, create a point in Rhino. I've set it to origin, doesn't really matter where it's located. And in order to take this information into Grasshopper, we'll take a parameters component and we'll indicate point. Again, right click it and set to 1 point. And then we could select that point we've created in Rhino. And now this, we know that it contains that information because it says one locally defined value and we have that green cross indicating point is there. Okay, so we'll want the move command, which we can find in transform, Euclidean, and anything that's basically a translation of an object like rotation or reorient can be found in this panel. So we'll be concerned with move, drag that in. It's asking for a geometry, which is our point here. Select that. And because it's already default value placed into the motions input, we can see that our point has been translated up 10 units in the Z direction. So here is where we're going to modify the value of our move of this point, and we'll set it with a random value from this component. So in order to determine range, we can right click it and go to set domain. So we could choose two different integers in which we can have our components select from, or we could go to our maths panel or maths tab and domain panel in which we could construct our own domain in which we could adjust the parameters if necessary with number sliders.
Just I want to explain what domain is. I'm not sure that everybody could you explain that, because I'm not sure that everybody familiar
Yeah,
with
so
term.
basically a domain is a range of numbers, and you'll have one that's lower value, one that's a higher value, and anything in between will be the domain of values that the component will choose from. So domain start, we can insert a number slider. So double click or press space to enter the keyword search. And a shortcut is just to type a value and you'll see that number slider appears. If it's one number, then it should be in between 1 and 10. And if it's 2 digits, it'll be between 10 and 100. So, and if it's a 0.7, for example, that'll be between 0 and 0.1. So that already gives you a solid range of numbers to select from. So we'll do something like 5. Oops. So 5, and then hit enter, and then you have your number slider already set to those extents. So we could start, place one start, and I'll just copy and paste another one, and we'll insert it here. So for our start, we'll want to have something of a lower value, like 1, for example, or 9. And we can input that into our range, and we'll know that that's applied because in our output, if we hover over top, it'll say that our domain starts from 1 and ends at 9, and that'll also read in the input value of our range. Okay, following that, we'll be concerned with number. And because we only have 1 point, the default value of 1 is fine. If we were to have multiple points, then we'd have to adjust this number based on how many geometries we'd need to have random values for. So right now, this is fine. And for our C, we could just copy one of our number sliders. And this one really doesn't matter. It just has to be an integer, and the seed will recognize, the component will recognize that that's a unique seed. So 9 will be different from 8, and those will produce different sets of values. So I will enlarge this a bit. Okay, drag this out. Right, and this should now generate, oh, before we insert that actually, now that we are inputting a number that's not the default, it needs a unit, a vector unit. So for this scenario, we'll probably want a Z unit. And you could find that in, where is it?
It should be in vector.
Vector? Why can't I see today?
Mhm.
Yeah, it should be in vector panel in the vector tab. Okay. So we'll connect our Z vector to the motion input in our move. And then from there, the value of which our point will move in the Z direction will be connected through the random component. You could see in the Rhino viewport that we have moved it, and if we hover over the output, it'll say that we are 8.2 approximately units in the Z direction. And when we change our slider at the seed input, we'll have different values that we could choose from. And there's all between the ranges of 1 and 9 that we've set in our domain. So if you were to change this, for example, then our seed will somewhat adjust to these new values. Another thing that we could consider is if we wanted to include movement in the negative direction, we can change our number slider, or because we have one already here in our domain start, we could connect it and use an expression instead to determine what the negative value would be. So can somebody tell me what expression we could use? So the value or the value we're using is x. What expression can we make with x to make it negative? It's simpler than you think.
Negative x.
Yeah, exactly. So x is just taking the value from this number slider. So if x were 2, then we would just place a negative, and that would become -2. And so now our domain is 1 to -1, and et cetera, et cetera. So when we change our seed, we're changing what values are being taken from our domain. Okay, now what happens if we are to have multiple geometries? What's a command? So I'm asking, what is a command that we can copy this point multiple times in one direction that we could use? Nobody? Okay, we could array it. Let's do a linear array. So where should we input this linear array? In between what two components would be logical? So we have a point value. We want to array it a few times. We put it in between the point and the move component. Okay, so it's asking for geometry, which we have, which is our point. We'll insert that there and remove it from the move component, and see in our Rhino viewport that it's now been copied multiple times in the x-axis. So that's fine for the direction, and you can see that the unit is 10 in between the copied components or copied points. So that's fine, and our count, we'll update that. So I'll take my number slider from here and I'll insert it into the count, and we'll say something like 5. So now in our output for the linear array, we can see that we have a list of 5 unique points, and you could type panel just to visualize it further or have it open. So it's one set with 5 items. Okay, so we can insert that now into our geometry. And what we'll notice is that they're all the same. So that's because we have 5 inputs into this geometry input for the move. But in our motion, we only have 1 value. So they're not equal. And you could tell because we have an individual line that's going into our motion input, but a double line into our geometry. And that's a visual indicator that this is a set with multiple items, and this is just 1 item. So we want these to match. And in order to do that, it has to be adjusted somehow. So what component do you think needs to be adjusted in this case?
Is it the number in the random?
Exactly. So if we hover over our number input, it's defaulted at 1, which means we're going to have 1 unique value, 1 unique value. But we have 5 points, so we want 5. We can definitely create a new number slider, or we could simply draw from this slider and enter into the input, and it should be consistent now. However many points are arrayed to however many random values we would like to insert. And you'll see that these lines, these connections have changed, so they are 1 set with multiple items, and that should work out now. All right, I think that's all. Now we'll move on to Leo's part, but does anybody have any questions so far?
Yes, please. Yes, if you think you are following.
Oh yeah, in the participants panel,
In the participant
give us
panels,
a
please.
check if you're good.
Yeah, click yes if you feel you're good. If you feel that something is unclear, you'd better ask. Even if you think you are good, but you still have some questions, ask questions in a chat. Like, even if this question seems to be not like strange, like, okay, very good. Eric, could you save this model and send it to me by email?
I have a question.
Okay, yes, please.
How does this arraying connect to the random input? Like like, you know how you started with random, how is that all connected to the array?
Okay, so the junction is our move component. It's taking information from our linear array, and we're also getting information from our random component over here. So the junction is at the move component, and Sorry, what was your question? Am I even answering it?
It's okay. No, I was just asking how the random, like the component random connects to like the array that we applied later on.
Yeah. So
You
Like, would
mean
the
to
whole
the
thing
to
still?
the array of points?
Yeah, like would the whole thing still work if the random component was in there?
You mean the panel? Do you mean the panel, or you mean the generated array of dots?
no,
No, the panel.
Oh, the panel here?
No, sorry, not the panel. The random, like the what do you call it?
Component?
The component itself.
Okay. So if I were to disable this,
Yeah.
then we are lacking information for this input. What we do have is information from our linear array, which we've created a point, we've copied it over a few times, and that's inserted into our geometry. So our move component understands that there are 6 values in which we will create a move from, but we are now lacking information of which direction, so which vector these points will move and how far they will move. And so that's where the random component and the construct domain comes into place. So these informations are merged together into this one component in order to create the action for the action for this move. Does that sort of answer?
Yeah.
So they're not really connected together. I mean, it might be confusing because we're using this this number slider in both cases, but think of it as just the number of arrays will need the same number of random values. And so instead of creating 2 number sliders like I have right now, and you can see that they're basically separate from each other until they reach the move component, because they will be consistent, these values, it's easier to just remove one and place it into both components so that they remain consistent with each other.
Okay, thank you.
Okay.
Okay, Eric, please save it and send it to me. And you can stop sharing, then I can start sharing. Could you stop sharing? Yeah, okay. While Eric is sending the model, I want to a little bit to reiterate what we learned previous time. Unfortunately, I haven't prepared illustration, so I hope I can draw it on the fly. That's what we learned from previous, like during our previous session. Like if this is a Grasshopper component, right? A Grasshopper component accepts several inputs. It's normal, like most of them accept several inputs, and we have seen like it can be a number of items to create, it can be some like a plane and some vector, etc. So just for this component to work, right? All components, most of the components have several inputs, and usually how and they have outputs, right? So and usually how it works, you just provide like you connect wires, right? You connect wires to the inputs. It's simple, pretty straight, connecting different elements. So you connect a wire. And it is usually just one. If it's just one value, then this block executes its operation and produces some output. So that's regular set, like that's how these components usually work. So I will just color it. It's hard for me. Okay. So, but the thing is that, and we will call it Grasshopper component. Okay. So, but the thing is that any Grasshopper component is written to process not one value per input, but a list of values. So it's a sequence of values which can be potentially fed into any input. So, for example, like what for our first input, we can visually represent values which are fed into this input, and basically it's a list. So we can represent it here. It will be not just one value. We do not know how many. We know that usually it should be more than one. Sometimes it's okay. Some inputs are optional, and you and some inputs can be ignored. But basically, it is a few. It is a list from, and even if it just, for example, here, like this will be list for this input. Now let's see, we will, just a moment. This will be a list of values for second input. And for example, here only one item is fed into this input. And then we have, for example, for this input, we have, sorry. One, two, three, 4, 5 items. So what will happen? How this element will process? Like if each list has only one element, we already know how it works. Just all, like this set of values, 1, 1, 1, will be processed, and some particular result like will be produced, right? If we are feeding several items, what will happen? Grasshopper does it. What Grasshopper does? Grasshopper. Okay, I will. Just a moment. I need to highlight this. Okay, and we will fill it. So this will be green. So Grasshopper distincts between all other items on the list and last item on the list. So, and last item on the list in a way has like it will be used if Grasshopper needs more information. What I mean, like here we have, like on different inputs, we have different number of items fed to the component. This component knows it can work only with sets of 1, 1, 1 value per each input. So what the Grasshopper wants to do, he wants equal length lists. And then it will do this. For the first run, it will take all items on the index 1 position, on the index 0 position of the lists. On the second run, it will take all items from the index 2nd position. For the third run, it will take all items in the index 3 position. it's index 2. Sorry, this is index 0, then index 1, then index 2, 2, right? So, but the thing is that this list is 5 items. So index 0, 1, 2, 3, 4. This list has only 1 item. What Grasshopper should do? Grasshopper does a very simple thing. If some list is shorter than it needs, basically it just repeats the last item. Like you won't see it, but that's what Grasshopper does. It just repeats the last item the number of times which is needed to make all lists equal length, right? So, and basically it will be the same item as the last item on the list. And for this second list, we had just 1 item. So this item just multiplied to have 5 copies, right? And for the first list, also last item, we have 3 items, and the last one will be duplicated basically 2 times to make this list 5 items list. And then, as we mentioned, what's just a moment, can I do that? Yes, I can. And I want it to be a little bit wider. Can I make it wait? Yeah. So, and then first run, the result will be produced from, should be transparent. Fill, can I make it transparent? No fill, yeah. First run, it will be items from index 0, then item from 0, index 1, index 2, index 3, index 4. So that's why, like, answering Ilse's question, my answer, like, I would add to Eric's answer that basically the trick is that once one list on this input, on the geometry input, is matched with a list on the movement input, and they match 1 by 1 because number of items are equal on both lists, and the fact that number of items are equal because this number of generated objects, it's the same for the random block and for the geometry generation, for linear array generated block. Okay, now let's move on. Just a moment, I will take Eric's file. Mm-hmm. Open document. Mm-hmm. Okay. Now we want to what we want to do, we want to make it, I want to make this example a little bit more interesting, a little bit more geometrical. So I want to generate a surface which will change shape according to some randomly generated numbers. And we are quite far, and we seem to be quite far from this, but actually Eric did everything, like he prepared everything for us to get to this point. So like, let's see where we are now. Now we will set one point, it is the point. So, and as Eric explained, so this array, this slider, it allows us to increase number of points generated in our linear array, and simultaneously all points are getting random positions, like they're slightly randomly moved in the direction, each of them. So that's what our current diagram does. So we want to create a surface. So if we want to create a surface, first of all, we need more, and what I'm thinking about, I want to generate a surface from defined by points. And now we have just one line of points. I want to have more lines of points. So I want to have more lines of points, and then surface will go through the lines, right? So my question to you, what would you suggest? What you suggest to get more lines, more series of points than just one, which we have now? How can we have more lines of points?
Can you array it in the other direction, like array the current line?
Absolutely. Absolutely. We used the array element before. Here we used an array element, and we can perfectly do it in the other direction too. So, for example, how we can do it? Let me see. It's transform. Oh, can we just type array? Linear array. Yeah, so we can connect this dot here. Connect this dot here. We can define number. Let's define it. Just I don't want to spend much time on this one. So it will be 10, and direction. It was. So you see, it is direction. It is in x direction, and this one we will make in so this is a vector in x direction, and we will make it a vector in y direction, right? So we'll, yeah, in y direction. So we'll do 5. Okay. So now we have here 10. We have, and we will fit it here. And you see immediately. So it was just one set. It was just one point, right? And one set, and then we changed it. Yeah, to our array. Just a moment. Yeah, and immediately we have several repetitive sets of points, and you see now if I'm changing the generative part, then they're all moving. All our sets of points, they're all moving simultaneously, right? The same, because basically we have like the pattern of movement. The pattern of movement is only one. Like it's one pattern of movement, and yes, now we have several sets of points, but the pattern of movement is the same, and it's applied. The same pattern is applied to all our points, and that's why they're all moving like in all sets. They're moving in the same similarly. Okay, I am more interested in getting something less uniform. So I want to have a little bit more interesting curve. So I won't use a linear array, like back to our one point and back to our one series. I want to use something more controllable. I want to have more control in Rhino on what points will be produced. So it will make probably my surface a little bit more interesting. So what I want to do, it will be front. Yeah, I think. So I will produce points by dividing a curve. Just a moment. Yeah, here it is. So I will draw a curve here, and let's try that. Somehow. So it will be my curve. So instead of the point, I will take a curve here. So I need the curve. It's another element. So, and I will use this curve, and then I want to divide it. So I just divide the curve. This is the curve, and I want to produce a particular number of dots. So, and I will feed these dots into my geometry. Okay, now I can control how many dots this curve is split, right? It's my one control, right? And also we were able to control just now. It is the seed, its direction. Oh, I see. I see. Yeah, the thing is, so this is how we created several series, right? What makes it a little bit strange, now we can control the curve, and it will change location of the series. We can change number of dots, but we are not controlling the size of the series, so we need to scale it up probably, just to make it just to keep the width and the length more or less under control and proportional. So probably the direction, so we need to scale up how the linear array is created, and I think what element? I think it should be a vector, and it is in x direction, right? So we need unit x vector probably, right? And we want to multiply it, right? X, yeah, how we can, and this one, it's scaling factor, right? Okay, so we will define a scaling factor for this vector, and let's say that it will go from 1 to 50. Okay, and then if we feed it here, okay, will it work? No, just a moment. X. Sorry, guys. I need to I need to think about it. So this is our linear array, right? And this is the direction. It is from X. So what this one produces, so it takes from one source 30.4. Yes, this is the value. And let's check what's the output. Yes, it is exactly what we expect. And this one, it's the geometry. Just a moment. Can we, if we use perspective? Yes, it does. Okay, yeah. So it moves it. It was just the wrong view. So now we can match our. So we control the spread of our series, and now with the curve, we can also control the spread, and we can also control the location of our points to a certain extent, right? So, and we just a little bit, and you see if we use just one dot, then we control number of items in the series, and also we control number of items in the series. Oh, it's the same. I see. No, it doesn't make much sense. Just a moment. So the thing is that we are controlling number of items in the series, and it's the same slider which controls how many it shouldn't how many items are in the linear array. It doesn't make much sense. We want to have an independent slider here. Okay, just a moment. Okay, and now we want an integer from 1 to 20, say. Okay, so now here we are controlling how many items in our series, and here we're controlling, okay, as we started from just one from just one point. Now we cannot produce one because curve gives us at least two, but basically now we are controlling how many points we are giving. The points are division points for our curve, and each point generates it causes generation of the series of dots of this length, right? So is it more or less clear? I hope so. Okay, now our question is, okay, back to our randomization problem. So all our, like, as we generate just, let's look at our panel now. Like, it's the panel of which represent the generated geometry. For now, we have 5 dots in each series, and we have 3 series basically. Like our curve is split, and it's split. Our curve creates 3 points, and then each point generates 5 points in the series, and we can see that here. So in this panel, we can see that we have 3 series of items, so 3 lists basically. This linear array element, it runs 3 times for each point on the curve, right? For first point on the curve, it generates this list. So it repeats this this point 4 times, moving it according to the specified direction, right? And creates this list. If we had only 1 point, it would be only 1 list, but we have 3. So other inputs, they have just 1 value. So it's the same parameters are applied to each point. So we have 1 list created for the first run, 2nd list created for the 2nd run, 3rd list created for the 3rd run. So we have 3 lists, and it is fed in this move element. This move element has 3 inputs on geometry, 3 lists of dots, and it has a list, 1 list on the motion. Like it's only 1 list. Let's see. Okay, we are, it's moving vector, what it says. Oh, it's now, just a moment. Why it's not. Yeah, this is a problem. So basically, if we split the curve, number of dots on the curve, it's, yeah. So it doesn't. Okay, and then 5. Just a moment. Okay, so what we have here, yeah, this is number. The thing which disturbs me, that this array has 4 elements, right? For example, now, and here we have more lists, 1, 2, 3, 4, 5 lists, and actually, what it means, like for each, for each list, just a moment. For each list on this input, this array will be applied. So this number of elements here is 4, and number of elements in this list is 1, 2, 3, 4, 5. So why the numbers are different? So number of elements here is 5 according to this, and actually here it's 4. Yeah, so this actually should be fed here. So it should be 5. Okay, now we have for each dot a series of 5, like a series of 5 is produced, of 5 dots is produced, right? So and the same number of, and now we're generating the same also 5 random Z units, right? So, and then what will happen here? Each of these lists, it's a list of lists. Each item on this list, it will be matched with this 1 list, and elements will be applied, so 1 by 1. So each dot will be, first dot will be moved according to this vector. Second dot will be moved according to this vector, like with index 1, etc. So each index here has a match here. So, and now they will be all moving simultaneously, right? You see at the same, yeah, the same movement, because basically it's applied equally to all generated series of the points. Now we want them to be applied differently. We do not want this, it will be the same movement for all our series of dots. We want movements to be different, and then our surface will become more wavy. But before we do that, let's create a surface. So we already have dots, and this pattern should be able to generate a surface. Let's see how this surface will look like. So we go to the surface panel, and obviously surface from points is what we need. So this element, and this element takes points. So we will fit geometry here. And our problem is, you see this wire, and it's like interrupted wire. And basically what it means in this case, that what we are feeding are not points. We are feeding lists of points. And we can see here. So we want, this element wants a list of points, and actually it takes many, like, lists of lists. So basically describing our series. But what will happen then, it will work taking first list as input parameter, second list as input parameter, third, etc. It's fine. It can generate several surfaces, but the problem is that actually these dots, they are just linear array, so they do not define any surface. So this element will fail. It's impossible to generate an array from this sequence of dots, to generate a surface from this sequence of dots, right? So what we need to flatten this, what they call flatten, like this output. We do not want it to be list of lists. We want to join all lists into one list. And we apply this transformation to this output, flatten. It's, yeah, in a way, it corresponds with Photoshop concept of flattening layers. So, and now we have everything in one list. So, and it's just a list of dots. And this is what this element wants. So now, am I correct? Yeah, I think so. And now, now we need to define U count. And I think, let me see. It is, I think it is this number is the U count. Let me see, I'm not sure actually. Is it this one? No, no. Yeah. Oh, yeah, we have only two. It's one value inherited from. Okay, it's, and you see the value is 5, and 1, 2, 3, 4, 5 here. Just, or we want to fit. Just I'm not sure what it takes as U. Is it what dimension we're taking as U? If we're taking this one, let me see. No, it won't take this. Okay. So then it should be this one. Okay. Okay. And obviously this number should be transformed as because it's not exactly the number of generated points. I think it's the number of generated points plus 1. Just let me see expression. Oh, a expression x plus 1. Let me see. No, I think it was this. Yes, minus 1. Okay, so and now it's a surface which will vary with our, like, it will follow our like randomization pattern. But the thing is, it's already like waves, but we want it to be a little bit more randomized. Right? So, and to make it a little bit more randomized, we need to match number of motion patterns with the number of point series which is fed to this element. So how can we do that? So how we can make this element to produce the exact same number of moving patterns as this element, as number of dots fed to the geometry. What do you think? So it is like number of dots, which is we are splitting our curve. Yeah, it's basically this, right? So our curve is split in 3 segments, right? And when the curve is split, you know, we can make it a little bit more visual. So this is basically if we think about this number slider as about if you think about this number slider as about number of points, then we can just split the curve by the number of points minus 1. So it will be x minus 1. It will be number of segments, and then number of points will be produced points will be exactly as specified by this slider. Then here this input should be corrected, so it's just x. Commit changes. No, is it a little? Oh no, it's just a moment. It should be plus 1. No, I'm a little bit. Why it's. Yeah, don't. Commit. Oh, we have. Yeah. It's not good to make changes on the fly. Sorry. Yeah, I will return to my previous model. Yeah, I don't want to screw things up on the fly. Okay. X minus 1. It just takes some time to analyze that. Okay, so basically to make this series move independently. We just need to feed more numbers into the seed parameter, because now this block works only once. It works. It takes the range. It takes number of items to generate, and it takes the seed just to produce some particular random sequence. If we give it more seeds than just one seed, it will generate, as this element does, it will generate series of series, a list of lists. And it is exactly what we want. And now we can see that this element generates how many lists? It generates basically it should generate 5 lists, right? Let's see. 1, 2, 3, 4. I believe it should be. No, it generates number of lists according to this slider, so it's 4. So it is this number plus 1. So it generates, it splits, the curve is split into 3 segments. So 3 segments gives us 4 points. So this one generates 4 series. So we will take we should have 4, so 1 more than 3. We should have 4 numbers fed into the seed in the seed output. How we can generate 4 numbers? It's easy. Like here, sequence is a way for us. Sequences provide a way to generate sequences of numbers. For example, we can use Fibonacci sequence. I think it should be familiar to you. And then we just feed this number into the number of elements. You know what? I will do something simpler. I will take what can we do? For example, I will take a series. Yeah, let's try to take a series. So it will be series, and series, how it works, it takes first number in this first number, then it's step side, so it's how much is increased between different numbers, and then it is the count. So first we already have the count, but we need to increase it by 1, because we know that the curve is actually split by this number plus 1. So it will be x plus 1, right? Now seed, it starts with 0. It's okay with us. And it increases with 1. It should be okay. We have no idea how this seed actually works and how it but they say that different numbers will generate completely different seeds will generate completely different sequences. So let's try to fit it here. So what we have here now, we have 4 different values for the seed: 0, 1, 2, and 3, right? And it immediately generates not just one list of movements, it generates 4 lists of movements, right? We have 4 lists here, we have 4 lists there. The number matches, so it means that this element will take first list on the list and first list on this list, right? And match them. So now, and then it will be done for the second position, so index 1, for the third position, for the fourth position. Let's see how it will work. Okay, so for example, if we, okay, now we want to be able to play with, like to change seed easily. To change seed easily, let's just feed the first, like it's the first number in the series. Let's, like it was 0, now we can change it. And let's see. So we're changing the number, the seed, and then our surface is changing shape. So what we can do now, we can, for example, we can increase number of dots we are splitting our curve on. We can make our surface longer, increasing number of elements in each series in our linear array, right? And then we can see how it waves. But the thing is also how it waves depends on the domain, because it is our allowance for a point to change, like to change position in z direction. So if we want to have a better control, we don't make it integer. We want it to be float, to have smoother changes in dot positions. So, and now you can see how it's like how the surface is changing smoother if we are just changing the domain. And this is how it, like what we are doing, changing seed, we basically completely changing our randomization patterns, and it's randomly changes our surface in an extent allowed by the range. If we make this range really big, then changes will be dramatic, right? If we make the range smaller, then changes will be just slight. Yeah, that's how we can. And basically, what we did, we just played with Eric's quite simple diagram, which allowed us to move one point in z direction randomly, right? And then with just a few changes, we created a surface which can change its shape with this randomization pattern. Okay. Okay, I would like to troubleshoot my problem and to find out what number actually I need to feed here, but I'm not sure that you're interested in that. So my question to you, like, if you have questions. How do you feel? Is it like too much, or like have you been able to follow? Okay, yeah.
Hi, Leo.
I
Yeah, I think it's good. The only thing I'm confused about is how do I change the direction of my linear array?
Oh, okay. Do you mean that you want different direction, or do you mean how it's changed in this diagram?
How it's changed in this diagram, because right now my like surface, everything is in one plane.
Oh, your surface, everything is. Could you share your screen?
Yeah.
Like if I stop sharing and you share your screen, then we can look into it. Is it okay?
Yep.
Okay.
Oh, I think you need to enable screen sharing.
Oh, okay, moment. Yes, you can share your screen.
Okay. So like here, everything is in one plane here. So I think it has something to do with, like, I missed a step.
Okay, one second. Could you just I would like to look at the diagram. Could you maximize it? Like maximize the diagram. I probably I do not need the geometry right now. If you
Oh,
maximize the diagram, yeah. And then let's see. So you have a curve and you're splitting the curve, right? And then it goes into the geometry. So it's your dots. So, and then you have this, yeah, you have X vector. Okay, it produces an array. It's good. So it goes here. Yes, you're fine here. Now, you have the domain and you have the domain, it defines the range. You generate, yes, you generate the same number, yes, as a number of dots in this series, you generate the same number. And you are, for the seed, yes, yeah, you generate several series. Okay, it's good. It's good. I do not think you're missing anything. Okay, let's go back to your, let's go to your geometry. Okay, where is your curve?
here.
Uh-huh, uh-huh. So could you in Grasshopper you see this icon at that like at the in the toolbar? Let's enable the mode when only highlighted elements are shown. Yes, and please highlight. Let's start highlighting. First, let's highlight the curve division. Okay, so these are our points, right? And number of points, 1, 2, 3, 4, 5. Okay, next highlight the series, linear array, like highlight the linear array. Okay, so we have, so they're produced. Could you change the perspective just to see, like, because like a perspective view, just to see how they were as, they look quite, yeah. Oh, I see. So your curve, redefine your curve, make your curve rotate at 90 degrees. So your curve goes in the same direction. Your curve goes in X direction and you need to make it go, yeah. And then it makes sense, right?
Yes, perfect.
Yeah. Yeah.
Okay. Thank you.
Yeah, you're welcome. Okay, yeah. Okay, so okay, good. Any questions? I'm afraid I'm sorry I was lost at a few things. Yeah, it's a bit hard to recreate this on the fly. Um, uh, I can if you are interested, I can troubleshoot the problem which I had, because I should be able to figure out why I wasn't like why how, there is an indicator. If you it's important troubleshoot. If something goes wrong, you should be able to troubleshoot your model and to figure out why numbers are not matching, why this surface wasn't created, why it was a normal wasn't a normal surface. So I should be able to do it, and I can do it. Just I didn't want to waste your time. If you think it's something interesting to you, I can do that now, and probably we can figure it out. But I'm not sure if you have time for that and if you're interested. If somebody is interested, I can just let me know. Okay, and I'm happy if you have been able to follow, and in general you don't have questions, so that's great. Next time we will probably go on and continue, and we will start exploring more like tool like Lunchbox, and we will like the set of tools which architects like to use. um, but you see, even when we are talking about quite simple things, its complexity increases so fast, because this way of thinking how you can reply something you already have to multiple elements, it's quite a steep learning curve, and you will need to get used to that. That's why I'm not so eager to introduce more complex elements, but we will start looking into them next time. Okay.